Hello, and welcome to the Rockford Systems Lathe and Grinder Safeguarding mini-webinar. My name is Carrie Halley. I'm the Vice President of Marketing and your moderator for today's session. Your presenter is Mr. Roger Harrison, our trainer, public speaker, and resident blogger with over 25,000 hours of machine safeguarding standards and regulations training experience to share with you today. The focus of today's webinar will be on the OSHA 29 CFR and ANSI B-11 standards as they relate to lathes and grinders. For anyone that feels that they need more in-depth training, we encourage you to consider our two-day training seminars, either at our or your location. Just a little bit about Rockford Systems. We deliver trusted machine safeguarding solutions for organizations working with industrial machinery. So we chose this topic today because there continues to be a pervasive lack of machine safeguarding in the United States. According to OSHA's top 10 most cited violations for 2017, machine guarding is number 8 and has been for several years now. We estimate that 50% of industrial machines are not properly safeguarded, resulting in a staggering 18,000 amputations, lacerations, crushing injuries, and abrasions per year, and more than 800 deaths per year, all due to insufficient safeguarding. So why should we safeguard machines? Well, it's the right thing to do, and it's a law. Risk assessments are a critical first step in the process, and let me repeat that. Assessments are the critical first step in the process. Here at Rockford Systems, we offer 2 different types of assessments, starting with the risk assessment, which is based on ANSI B-11 2015, which provides a hazard score with the risk level for each machine, as well as some high-level suggestions to lower the hazard level and detailed documentation that outline the results. So the final output from a risk assessment is a hazard report with a risk prioritization. We also offer a more detailed assessment, which we call the machine safeguarding assessment, which is based on ANSI B-11 and also OSHA regulations. In the machine safeguarding assessment, each machine is audited for compliance, and customized proposals with very specific products and services are recommended that would bring the machines into full compliance to OSHA standards and to best safety practices. This would also include a detailed cost proposal for what it would actually take to bring those machines into full compliance. But either way, depending on what your company needs, the assessment is the critical first step in the process. Now I'm going to turn it over to Roger, who's going to get into more details on regulations and standards and cover safeguarding methodology for lathes and grinders.
Thank you. We're going to talk about OSHA regulations and ANSI standards as they deal with metal processing machines. First thing, any safety-related issue is covered by OSHA's 5A1 General Duty Clause, which is the employer's responsibility to furnish a safe and healthful workplace free from recognized hazards likely to cause death or serious physical harm. There are employee responsibilities in there as well for employees to follow the rules and regulations that apply to their own actions and conduct. So that's the most general thing. Underneath that, we've got 1910-212, the general requirements for all machines that require the employer to protect the operator and other employees in the machine area from exposures to recognized hazards, such as point of operation hazards, because every machine has at least one point of operation where the work is done on the material being processed. Protect those with guards, devices, methods, or some combination of those 3. Ingoing nip points require covers up to a 7-foot level to prevent people's hair and clothing from getting tangled up in them. Rotating parts, same thing. Covers up to 7 feet to meet OSHA, 8 feet to meet ANSI. Flying chips and sparks are covered in OSHA by saying you need some sort of chip or coolant shield to control the chips from hitting the operator in the upper body or collecting on the floor, creating a slip-trip hazard. Now, what you have here on this list is not a complete list of hazards or a complete list of safeguarding. They just list a few of these items under examples of safeguarding at the bottom as barrier guards, two-hand actuators, and electronic safety devices. The general requirements for all machines say that the guarding device has to be in conformity with any appropriate standards. Well, appropriate standards logically would be some of the ANSI standards from which the OSHA regulations came from. All of that started back, the ANSI standards, that is, started back in the 1920s. So OSHA had a window of opportunity in the early 70s to adopt some of those ANSI B-11 standards into their own regulation, rebadging them under their own clause and paragraph numbers. But that only lasted a few years. So now it takes an act of Congress to change an OSHA regulation. The ANSI B-11 standards that we're going to address are 2 of 24 of them. Those being lathes, we're talking about manual engine lathes now, not CNC turning centers, which is covered under ANSI B-11-22, which is beyond the scope of this class. The other one we're going to cover is ANSI B-11-9 on grinding machines. Yes, the ANSI standard is current, but the OSHA regulation 1910.215 takes precedent over the ANSI standard. The second half of that list is listed here, along with robot safeguarding, which is not in the ANSI B-11 series, but it is part of the American National Standards Institute. We'll come back to that. So, up at the top here, B-11-19, safeguarding methods, is probably the best standard to get if you want to get an overall education of guards, devices, and methods. Because in recent years, they've taken some of the details that used to be in the other 24 standards, taken this safeguarding stuff and put it in B-11-19. So this gives you a very good education in one standard, B-11-19, which is updated, I think, last in 2010. Come down at the bottom, there's some B-11 technical reports, which is how a standard starts out because before it becomes an actual standard. So a technical report like technical report number 3-2000 started out as a TR and is now ANSI B-11-0-2015, as Kerry mentioned before. So the Code of Federal Regulations under Subpart O now, just Subpart O for machinery machine safeguarding, has 2 types of regulations, vertical or machine specific and horizontal or general. Now, horizontal or general regulations cross all machines and industries. Machine specific usually has a list of do's and don'ts. It's very particular in what you have and what you don't have on a machine. So those would include 1910-215 on abrasive wheel machinery. Yes, we're going to talk about that today. And mechanical power presses, which we covered in another webinar. Now, back up at the top, most machines fall under 1910-212. Hundreds of different categories fall under 212 because there is no vertical or machine-specific regulation for them. So, in a 10-year period, there were 60 lathe injuries, usually involving fingers, hands, and arms, and some fatalities, by the way. 33 lathe fatalities in that same time period. So if you're looking these up, you might find older references to standard industrial classifications and newer ones to NAICS, the North American Industrial Classification System, NAICS. So you might look at both of them if you're looking machines up. What's a properly safeguarded lathe look like? We're talking about an engine lathe here that in this case depicts a machine from the 1930s, of which there are still many out there. So everything you see with a caption is what we're going to address. Shields, electrical updates, danger and warning signs, and so on. Any rotating components that could tangle up somebody's hair or clothing need covers up to at least the 7-foot level from the floor. And OSHA always makes a an effort to look for all of these exposures. So make sure everything you have that rotates is covered. The other thing you may want to consider on lathes is the horizontal rotating components down below the carriage of the machine. So these are covered by telescopic stainless steel sleeves for lead screws, feed rods, traverse rods, camshafts, because even though they travel slowly, they can tangle somebody up in it, and there's a lot of torque in these things, so they can really pull somebody in and injure them badly or even kill them. If you want an example of that, you can Google Yale, that's Y-A-L-E, lathe fatality. Describes a situation where a young woman lost her life about 7 years ago by getting tangled up in these horizontal components and had not properly restrained her hair. So these are available in different sizes. Our company does not happen to offer them, but there are two companies who do up in the top right corner here. You may want to take down those websites. So why don't more companies use these is a question we get. And I think probably the question is, or the answer is, that to put these on is time consuming. They occasionally have to be removed to clean them out. Plus you lose a certain amount of carriage travel, like down here. This largest segment contains all the other segments when the carriage is over on the right-hand side. But that's 6 inches long, you lose 6 inches of carriage travel. And the same thing goes to the other side that you can't see here. But they are good protection from somebody getting tangled up in these components. Chuck shields covering the rotating work holder is important, even though that does not completely cover the rotating work holder. You can reach in the side of it, you could reach in from the other corner. There is access, but it will inadvertently keep you from coming in contact with the rotating chuck and getting tangled up in it. So the one on the left is the simplest, probably the least expensive. It's all polycarbonate with a hinge. You got to have a hinge to fold these up out of the way, get them out of the way for a new setup. The middle one is all steel, but it's got a visibility window that, as you can see, is replaceable because that does eventually cloud up or scratch up. The one on the right is all steel and has two different hinges to get it up out of your way. So those are typical, lots of different manufacturers of them, including Rockford Systems. There's an engine lathe with two different shields, but the difference is these shields are electrically interlocked. Look over on the right-hand side here. There's an interlock inside that enclosure. There's another interlock back here that you can't see. Do you have to have interlocks on shields to meet U.S. standards and regulations? No, not yet anyway. This is something that has become prevalent in Western European countries, which have always had more stringent safeguarding standards than we have, and also in Canada. So it's growing here. Whether it'll ever be in OSHA specifically, hard to say. Chip coolant shields. These are to supplement your PPE. You can think of these picking up where PPE leaves off. Some are all metal and some have a visibility window. Some are even polycarbonate only, like the one on the far right side attached with the magnet. So these are to keep the chips off of your upper body as well as prevent chips from accumulating in the eye of the workspace, creating a slip trip hazard. So chip coolant hazards, you may have those on a lathe like this, for which you can position a shield, in this case magnetically mounted. You may have them on a Bridgeport mill, like the one up at the top. And by the way, it's a very common example of a three-sided shield on angles. And the same with this one on a drill press. Occasionally brand new machines will come with these shields, but in most cases they have to be retrofitted or added on later. There's an engine lathe, a small one sitting on a movable stand because it's used at tool shows, that has a couple of different emergency stop buttons, as you can see here. One here, and a cable. It goes all the way across the front, referred to as a grab wire or a rope pull e-stop button. It's also got one of those interlock chuck shields, we mentioned that before, and the rotating components are covered over here and have an interlock switch right up there, so if you open that cover, you disable the machine. Self-ejecting chuck wrenches. One of the #1 issues with safety people, that compliance officers, insurance company, loss control engineers, is they find that accidents have happened where people take the standard chuck wrench provided by the lathe manufacturer and store it in the chuck when they're not using the chuck wrench, which is not a good safety practice. Because what they do is forget the chuck wrench is in there, turn the lathe on while it's still in the chuck, and send it flying. That's caused some fatalities and taken out some eyes as well. So spring-loaded self-ejecting wrenches like this require that you hold them into the chuck. You have to have downward pressure as you're turning the handles. If you let the chuck wrench go, it pops out of the chuck, preventing you from accidentally leaving it in there. So that is a big deal, and OSHA has been known to write that up quite frequently in 1910-212 general requirements, even though there's nothing specific in their regulation, because it has caused so many accidents and even a word that always catches their attention, fatalities. As far as updates on electrical, a magnetic motor starter. Main motor starter should be magnetic to provide dropout protection, also known as anti-restart. So if you lose power while the machine is running, power comes back later, you don't want a surprise restart of the machine. How can you tell if your main motor starter is magnetic and therefore provides dropout protection or anti-restart? The answer would be a spring-loaded start button. Here they say on button. Spring-loaded, not a mechanical switch, but something that'll pop back out when you release it. Same goes for this one, same goes for this one. This has a disconnect switch, happens to be a rotary switch where the only place you can put a lock is in the off position, right there. Also has an emergency stop button, which we're going to discuss more about later. NFPA 79, the National Fire Protection Association 79 is the number, the electrical standard for industrial machinery, 2015 version. This has requirements for power disconnects, motor starters, as we just discussed, voltage reduction using step-down transformers, properly grounded circuits, emergency stops, and more, like 3 different categories for motor stop controls, as an example. So this is an important one to get a hold of, along with NFPA 70E, which deals with arc flash for people that have to work on electrical panels while they're energized and the protective equipment they need to safely do that. Speaking of emergency stop buttons, the new ones in NFPA 79 have to be a red mushroom style button. You don't want a little tiny one, it should be a mushroom shape like this, with a manual latch feature. So when you push down the E-stop, it locks in the engaged position. Before you can restart the machine, you have to give the button a quarter turn clockwise to reset it to the disengaged position, which is what you're looking at on the right-hand side. An emergency stop, it's got to have a yellow background, and it's got to be readily accessible to the operator or operators, depending on where they're working on the machine. Some machines are large enough to require 2 red emergency stop buttons. Most all ANSI B-11 standards say that every machine that will tolerate an emergency stop should have one. Tolerate meaning be able to stop quickly. There are some machines that are not able to being able to stop quickly. How about a freestanding shield to contain the chips in your own workspace? We manufacture this extruded aluminum shield. There's others out there, but it's to keep your chips in your space, not allow them in the aisle. Moving on to grinders. Now, in the case of grinders, as I said before, this is a machine-specific regulation. So if you look in OSHA's website under OSHA.gov, you'll find a list of do's and don'ts, not these, as well as the most common violations on them. There are 2 active and current ANSI standards, B-11-9 for grinding machines and B-7-1 for abrasive wheels. So this, you go to the OSHA regulation because it's vertical, machine-specific. The 2 ANSI standards are secondary as far as importance goes. As far as grinder accidents in a 7-year period, it's usually from an exploding wheel, if you look through this list, and usually causes damage to the hands, finger, arm, sometimes eye and face injuries, lacerations. There's some other ones down at the bottom, including 3 fatalities. So a bench or a pedestal grinder. Testing before you mount the wheel is required by OSHA, and you should document, by the way, that you're doing that and what your procedures are, which is basically to suspend the grinding wheel from its center hole, then tap it around its outside diameter on the edge, about an inch down from the outside diameter, to see if you can ring it like a bell-like sound, as opposed to the thud or cracked plate sound you get if the wheel is cracked. And you never, ever want to mount a cracked grinding wheel. There's also a vibratory sand test using a vibration table for large grinding wheels. So you put it on that table, spread out the sand real thin, turn the vibration table on, and if there's a crack in the wheel, it will migrate away from the crack. Notice there are several holes for the wheel cover here, and some of them are missing the connectors, the hardware to attach that thing, bolt it shut. That would be an OSHA issue as well. The red curved arrow tells you the forward direction of the grinder, so that if you have three-phase power and the power becomes disconnected, then when you reconnect the power, you accidentally reverse the electrical phases, you'd have a grinding wheel running backwards, which is very dangerous. 1/4-inch maximum opening between the tongue guard and the wheel. Tongue guard, also known as the spark arrestor. 1/4-inch max opening. We talked about a wheel cover that covers the spindle and the nut like this one does. Yes, that's a requirement. And the requirement that you have no more than an 1/8-inch opening between the work rest and the wheel. That's a big one right there. In fact, that's the #1 machine guarding violation in the whole country. It has been for 46 years since OSHA came out in all 50 states, whether it's state or federal OSHA that administrates your particular state. I think there's 23 states that have a state-approved plan. So 1/4-inch between the wheel and the tongue guard, 1/8-inch between the wheel and the work rest. You should have some sort of a measurement gauge just for quick access. I mean, there's no requirement to have the gauge. So if we look in OSHA, they say the maximum wheel opening can be no more than 90 degrees, the total opening. You want to eliminate the wide spread that you would get if the wheel had too small a cover. Seen people open up grinding wheel covers up to 180 degrees. Well, that gives you a really wide shot if the wheel should explode in front, right in front of the wheel. I mean, right in front of the operator that's standing there. Then 65 degrees maximum opening between the horizontal plane and the top of the opening. So you go with OSHA first, then you can see if there's other ANSI standard references. So here's some grinder shields, direct mount or magnetic mount, and here's the same thing with an electrical interlock switch. No, this is not going to give you a quicker stop, but it would require that you put the shield back down before you can turn the grinder back on. So before and after shielding on a grinder. LockoutTagout. Yes, that applies to any industrial machine, including grinders, keeping in mind there is a long coast downtime associated with grinders. Sometimes to deal with the long coast downtime, they'll install a cover over the wheel as it coasts down, because it sometimes takes several minutes, and that's what these sections of guarding that are custom sized are designed to do. Danger signs and labels should have pictograms, graphics on them, with international symbols, preferably, as opposed to just signs with verbiage like older signs used to have.
Okay, well, thank you, Roger, for your great overview of lathe and grinder safeguarding. If you do have any questions about this material, please feel free to email Roger at roger.harrison@rockfordsystems.com. Also, as I said at the beginning, if you would like a more in-depth understanding of lathe and grinder safeguarding, as well as a whole bunch of other machines, we invite you to attend our 2.5-day machine safeguarding seminars here at our headquarters training center in Rockford, Illinois, about 50 miles northwest of Chicago, or we are happy to come to your location and provide the training as well. In addition, we do offer OSHA 10-hour general industry, 30-hour general industry, and hazard communications classes. For more information about training, visit rockfordsystems.com/seminars, or go to our training tab and find what you're looking for. Okay, with that, I think we're done. We invite you to join us each month for a mini webinar. In February 2018, we'll be having our robot safeguarding webinar, and feel free to sign up for that on our website. Thank you. Bye-bye.